All right, day 25, lesson 5.2. We did slow walk it through lesson 5.1. We broke it up into a day, and you got an extra day after that. So 3 days for essentially one lesson. So as we start the week off here on a Monday, day 25, let's get into some more three-dimensional figures and some measurements about them. So we're going to start getting into this measurement called volume. And I know we've all heard of what volume is. No relation to the volume when we talk about noise levels. We're talking about space. And we're talking about space three-dimensionally. So volume of a solid is really looking at area in 3 dimensions. Now, our dimensions that we're talking about is we have a point. A point has no size, so there's no dimension to a point. But once we get 2 points, we are one-dimensional. Meaning if we had an equation for a line, it would be x equals 1 to the first power. Now, if we bring in maybe a point down here, or maybe over here, and we have like an xy axis, now we're moving in 2 dimensions. And now if I was able to move off my paper, maybe float up in the air or go down in, that would be the 3rd dimension. So let's imagine we have, let's see if I can do, there we go, a piece of paper. A piece of paper is 2-dimensional. We can find the area of that piece of paper. That is a unit 2 type question. What is the area of that rectangle? And I want you guys to look at this as a perspective if that's sitting on a table, so you're looking at it a little bit at an angle, trying to look at that 3-dimensionally. And then I come and take another piece of paper and I stack it on top. And then I stack it on top again. And we keep stacking pieces of paper on top of itself. We now have taken a 2-dimensional rectangle and have turned it into a 3-dimensional stack of paper. The only thing we did though is we replicated this red base a bunch of times, and then whatever piece of paper is on top is going to have that same red base. So think of a stack of paper that you'd be putting to a printer or a ream of paper. It's basically looking at area in 3 dimensions. So for volume, we will look at the relationship between the area of the base, which is a unit 2 type problem, and the height. The height's going to tell us how many times do I stack, how many pieces of paper high, how 3-dimensional do we want it to be. So the volume can be thought of as stacking the base's area on top of each other until it reaches the top. That's why the bases of a prism have to be congruent and parallel, because essentially it used to be on the bottom and then it's stacked and now it's up here. So I want us to focus right now, and if you have a pencil or if you have a highlighter or different colors, I want you to focus on the very first thing is what is the base and what is the shape. This prism has a rectangular base, so it's a rectangular prism. Notice we can identify that base on the top and on the bottom. The height is the distance between the bases. And I'm going to say it that way because if I was to push this thing over, where the base was not technically on the top and bottom, maybe it was on the front and back or left and right, the height is always the distance between the two bases. So in this case, when we have a rectangle, for the base, we will calculate that area. Instead of A equals, we're going to call it B equals length times width. Here our base is a triangle. So the area of the base is the base of the triangle times the height of the triangle divided by 2. Notice lowercase b, capital B. There's a reason for that. Lowercase h, capital H. We don't want to confuse them. The lowercase ones, we're just talking about the base of the triangle. And so maybe this is the base of the triangle. And this is the height of the triangle, depending on what type of triangle it is. Here we have a pentagon. Since it's a prism, that same pentagon is on top. But it doesn't matter if it was a hexagon or a heptagon. We're going to just say, like we have in Unit 2, this is an n-gon. So B equals little a times P divided by 2. Remember, little a goes from the center to the side. P is the perimeter. Everything we're doing right now is just Unit 2. We have a circular base. So the area of a circle is going to be pi r squared. Just like that. So to find the volume, the inside three-dimensional space, volume is going to equal the area of the base that you identify. So you're going to calculate the area of that base, and then you're going to multiply it by however high that would stack. I stopped putting in my green H's here. So volume equals B times H. Think about this. B, depending on the shape of the base, you're just using one of these formulas. So basically, it's a unit 2 type problem, and then you're just multiplying it by one more number. That's the only difference between unit 2 and unit 5 in this lesson. So first thing I'm going to do, I'm going to identify the base. Now, you might say it's the bottom, and you can do that. That's fine. I'm going to throw a curveball here and say this thing fell over. So the base is actually on the left and the right. So volume equals base times height. So where's my height? Since I chose my bases to be on the left and right, the height is going to be right here. It's the distance between the two bases. So volume equals, I'm just going to take out my red capital B and my green capital H, and I'm just going to put parentheses and just allow me to write things in place of those. So we know H is 13. So what is B going to calculate to be? B is length times width, which is 5 times 3. So volume equals 15 times 13, which is 195. Centimeters cubed, because we're in 3 dimensions. I think that's a pretty good flow of how to follow this problem. Let me do it just one more way, just in case I did it a little bit differently than your instincts would have told you to do it. If you were thinking that the base is down here, that's fine. Then your height would be right here. Also, feel free to go to the side and say B equals 3 times 13. So B equals 39. Height equals 5. And then come back to your formula and plug in 39 times 5. I did all this work. I stayed in my formula just because from experience, sometimes when you pop over to the side and do some work, you forget where to go back to. So I recommend just trying to stay in your formula. So V equals 39 times 5, which is 195. Same thing. All right, what is the shape of the base? Is it this bottom rectangle? The answer is no, because there is not a rectangle on top that we would keep stacking that rectangle on top to hit. This thing fell over. It's a triangle and a triangle back here. The height is the distance between. So volume equals base times height. So volume equals, my height is 3. And my base, since it's a triangle, B equals B times H divided by 2. So I'm asking myself, what is the base of the triangle? 3. What is the height of the triangle? 10. So volume equals 15, that's 30 divided by 2 times 3, 45 cubic yards. Find the volume. What's the shape of the base? It's a circle. And the height is 3. So volume equals base times height. Since it's a circle, B equals pi r squared. Now I'm still going to the side to show you guys the formula you should be using, but I'm staying inside my formula here. So pi r is 2. So that's volume equals 4 pi times 3, which is 12 pi, which is a nice way to leave it. But when I ask you your questions, I'm going to have you guys round these for me. So that's 37.69. 37.7 cubic inches. All right, let's try and be creative here. Let's say that our base is right here. The thing about a rectangular prism, any two opposite sides can be bases. So that makes 10 my height. So volume equals base times height. And when I say base, I mean volume of the base. Since it's a rectangle, it's going to be length times width, which is 14 times 7 for me. Notice if you chose down here, you would have done 10 times 4 times 17. No matter how you do it, you're just going to multiply length times width times height. Rectangular prisms are pretty easy. It's just multiplying the 3 dimensions. It's 170 times 4. That's 680. Cubic meters. All right, my base here is a pentagon. My height So volume is base times height. So since it's an n-gon, B equals A times P divided by 2. A is 5.5. Perimeter is 5/8, which is 40. Divided by 2. So volume equals 110 times 8. So volume equals 880 cubic inches. So this is basically a problem above, but there's no picture. It's just all written for us. So we have a hexagonal prism, which is telling me n-gon. So B equals A times P divided by 2. And it has an apothem of 4.3, so I can keep working right there if I want. What's the perimeter going to be? If it's 5 yards on each side and it's a hexagon, so that's 5 times 6. Hexagon is 6 sides. That's 64.5. So volume equals 64.5 times the height, which is 5 yards tall. $322.5 cubic yards. All right, we'll pick up here for the next lesson. But I just want you guys to keep in mind the simplicity of that. Identify where the bases are, what are the shapes, based on what shape they are, what formula are you going to use to find the area of that. So that's where that capital B equal comes into play. That's a unit 2 type problem, and then just multiply it by the distance between those two bases. Okay, make sure you guys contact me with any questions.